This is blockchain theory part 2. This is the link, and let's see the part 2. Click this blockchain demo part 2. So this guy explaining the key generation and signing and verifying the signature. Here you can see this video, and this video is about 8 minutes to understand. Okay, let me explain this. Clicking this keys link. Here you can see the private key and public key. These two key user need to remember or need to save to do transaction, like real-time transaction to send or receive coin. So here this is, if you type any key, it will create a unique public key. So this is SHA-256 algorithm applied. So, and using RSA algorithms, signature will be verified. Anyway, what you need to understand for now is, for a specific private key, there will be a specific public key, and in real time from this public key a new Bitcoin address can be achieved, and this private key you cannot share and this public key you can share. From this private key, anyone can get this public key possible to achieve. Let's cut this and paste it here. You can see the same key, but from this public key you cannot get this exact private key. So this is one way gateway. This SHA-256 algorithm you need to understand for now. So let me click this random. So this is my private key and public key. Let's create a signature using private key. Clicking signatures link. Here in real time, before transaction, here public key, and here $20 money, and again public key, another user's public key. This data, and using the private key, my private key, need to create a signature. We cannot share this private key, but we can share this signature. This signature generated after using this data and this private key. From this signature cannot be retrieved this private key. So for now the user can share this matches and this signature but cannot share private key. Let me show you. Click this verify. You can see this signature belongs to this signature, and this user public key is this public key. So if I click verify now, it is verified because all data is correct. But if I try to temper this data, I change the data, but signature is for another message. If I click verify now, this is invalid because the signature not matched with this message. Need to be same exactly. This information and this information should be same. If you try to change this one and try to click verify, it cannot. So everything should be same. This is the beauty of RSA algorithm. Even you don't understand from this theory, no problem. When we do practical and build our blockchain client application, you will understand everything. Let me show you real-time transaction, how this transaction happen. So this is me, my public key, and this is my private key, and I want to send $20 to another person's public key. This is another person's public key. So I want to give this person $20. So what I need to do this transaction, I cannot share this private key. I need to generate signature. So I give my public key, my private key, and another user's public key and $20, and all this information will be used to generate this signature. So this signature I can share now. Like I can share this signature, this value, this public key, and this public key. I cannot share this private key. Let me show you how to verify. Here you see no private key. This is the message, public key, this is another user's public key, and the signature. If I verify, it's green color. If I try to change the value and try to verify, you see red. Because this signature belongs to only to this $20. You cannot just change it. So this is highly secured. And this is the way the real transaction works. And I will show you in our blockchain client API. And this is the real blockchain. Like what information actually exists in the transaction. Here you can see the block and nonce and the transaction. This guy, this public key giving these 2 coin to this public key, and also this transaction has the signature this. And if anyone try to tamper this data, the whole block is invalid. So based on this, hacker want to mine this, remine. But the problem is this signature is still invalid. So cannot mine. So this is highly secured. So this is the real block in a blockchain. The transaction and with signature is stored. This is the whole transaction. Here in real time, there are approximately 3000 transaction, 1 MB, 1 megabyte. So all you need to understand, to user need to memorize this public and private key, and private key, whatever you write, you will get a specific public key. From this private key, anyone can get this public key, and this private key you cannot share. And how transaction happen, user share only signature, not private key. This signature and this public key is enough to verify. That's it for today. Thank you for watching.